Hello, I'm Brian Dean. I'm a professor here at Oakland University in the Electrical and Computer Engineering Department. We're currently standing in the Circuits Lab in room 556 in the Engineering Center. In this lab we have 15 stations, and at each station we usually sit 2 students, so this lab can hold up to 30 students at a time. We have 3 courses this lab serves: EGR 2400, ECE 2005, and BE 3150. The 2400 class is an Introduction to Electrical and Computer Engineering course that all students are required to take. The 2005 class is focused on electrical and computer engineering programs, and then Bioengineering 3150 is a bioinstrumentation class required for all bioengineers. With all these required courses running each week, we have up to 300 students that are in this lab during the week, and we run the lab from Monday through Saturday. In this room, we teach students everything from digital circuits and analog circuits. We introduce it in 2400 and we expound upon it in 2005. And then in the bioengineering class, we create our own electrocardiogram circuit. We hook ourselves up and test out circuits to see our heart waves and things like that on the oscilloscopes. This is one of our stations in the lab. It has a power supply, a multimeter, a function generator, and an oscilloscope. All of these come from Agilent Technologies. We use these devices to test our circuits, provide power, and look at output readings from the circuits. We have a computer at every station that does simulations for us and also allows us to do auto code generation for the FPGA board that's on each station. The FPGA board is from Agilent, and it runs a Xilinx FPGA chip on the board. What we have here at this station is 2 different labs. One of the labs is from EGR 2400, where we're teaching students how to connect up gates to each other and get them to do something specific. And in this lab, students have to design the circuit from scratch in the pre-lab, and then they come in and wire it up to test their circuit to make sure it's working as they intend it to when they get to lab. The other circuit we have hooked up, an experiment we have hooked up, is from our 2005 class that is a little bit more advanced, where we are analyzing and testing a series RLC circuit that is currently underdamped, and the students can look at the damping ratio and the natural frequency and figure out theoretically what the right answers are for those, and then they can come in and test it using a pulse waveform going into the circuit and using an oscilloscope to look at the ripple effect from the underdamped nature of the circuit to get that information out from the actual test and confirm their results that they got before they came to lab. Like most rooms in the Engineering Center, we have a secure lab where only professors and TAs have access through a card swipe, and the students have access if a TA is present in the room. This is a fairly safe lab with low voltage and low current, and so we have the standard safety equipment within this lab. We have an emergency management guide, a fire extinguisher, and safety glasses.